So welcome once again. So now we are going to discuss the iterative way of in-order traversal. So the question will be same. So they will give a root, that is root of the binary tree is given, that means reference to this one is being given, and we have to return the in-order traversal of this entire tree. So now let us understand the iterative approach of this particular in-order traversal. So first thing, now I am going to consider one example. Let the tree be 1, 2 and then 3. So what I am going to do, so here the basic funda is that whenever iterative thing is asked in the case of in-order traversal, you have to use the stack here, and along you have to must and should you have to use the stack here. So what I am going to do, so I am going to consider the stack here. So first the reference of the tree will be at so they will give the root node, right? That means the pointer to this root node they have given, that is the root here. So root has been given, and what we have to do, so first thing, so if this particular root is not null, I have to push this element into the stack. So I have pushed the node 1 into the stack, and after that move on to the leftmost node. So move on to the left node. So now I have so 2 here, so that means so the root is not null, so hence I have pushed it into the stack. So again, so this particular so root is now present at 2. Now again I am going to move to this so roots next, so and this is going to be null here. So when this particular root which is present, so it is going to be null, then in that particular case let us pop this 2 out of the stack. So and this, and then let us store the reference of that particular 2 in the root. That means root is now pointing on 2 here, that means we are tracing back. So then after popping this out, I am going to print so this particular root's value. So that means now root has the reference to 2, so I have to print the root's value, that is 2 has been printed. Then I have popped this 2 out of the stack, and after doing this I have to move to the roots right. So I have to move to roots right now. So I have to check so whether the roots right is present or not. That means I have to move here. So root is present here on the 2, and I have to move here. So as this particular so root thing is also null, that means roots right is also null. So again what we have to do, so the root becomes null once again. So root will be null once again. The root is going to be null. So I have already said if the root is null, then what should I do? I have to pop the element which is present, that means the topmost element present in the stack, out of that particular stack. Now the root is going to become 1. So as the root is 1 here, that means root is pointing on 1, I have to print roots 1, and then I have to pop this element out of this stack. So after completing this one, I have to move to roots right here. So now the root is going to be what? Now the root which is present, the root is going to be 3 now. So after doing this, I have to if the root is not null, then I have to push this 3 inside the stack. After that I will move on to the left subtree of this 3, but it is null. So what I have to do, I have to pop this 3 out of the stack, and I have to store it in the root. And after that I have, now the root is present on 3, so I have to print 3 here, and I have to move to roots roots right, so which is also null. But my stack is empty already, so hence I am going to terminate the loop and I am going to return this 213. So in general, the basic thing is that, so if, okay, so the basic thing, so I'll sum up. So if, okay, the root which is present, okay, so one second. So if the root is not null, so that means the root is not null, so what I have to do, okay, if the root is not null, then I have to push the element, that means push the root into the stack, and then I have to traverse to the left subtree. Okay, so suppose if the root is equivalent to null, then in that particular case I have to, okay, store the topmost element of the stack, and then I have to pop that element out of the stack. Then what I should do, I have to print that particular element, that is, okay, so if we want to return the vector, then we are going to push that element into the, okay, vector. So I am just saying that, okay, let us print that inorder traversal. So then I am going to print the root's value here. So okay, in our question they have asked us about the vector, so hence if I consider the inorder, so then inorder dot, okay, so push back, so root's value, so root's value is being pushed inside that, and then I have to move to the right subtree. Okay, so and this loop is going to continue until the stack is, either the stack is not empty or root is not null. So this is the, okay, inorder traversal. So now let us, okay, code for that. So first thing, suppose if the root which is present is equivalent to null, in that particular case I am going to return an empty list. Okay, if it is not null, then I am going to declare a vector named, okay, so vector, okay, so inorder vector, and then I want a stack, okay, so we also require a stack, and let this stack be of type tree node star s. So and here the tree node is being given, so val is present, that means the data left pointer and the right pointer is present. So now what we'll do means, okay, until the stack dot empty is equivalent to false, that means the stack is not empty. So what we'll do, if the root is not null, then in that particular case I am going to push the root into the stack, and then I am going to traverse the left subtree. I am going to move on to the, okay, left part of the subtree. Suppose if the root becomes null, that means the root has reached the null point, that means we have, okay, we'll move from, okay, root to the left child, then to the left child, like that. And if we reach the null, that means if we reach the left child of the leaf node, then in that particular case root will be null. In that particular case I am going to pop the element, okay, I am going to take the reference of the element which is present inside the stack using the s.top function, and after that I am going to pop that element out of the stack, and after that I have to push that particular element into my stack. Okay, so that means I have to, okay, so push that, okay, the element which is present in the root, now its value into the inorder stack, and after that what I'll do, I'll just move on to the, okay, so roots right now. So at last I am going to return the inorder. So now let us, okay, so run and, okay, so see whether this particular code works or not. So here it is giving some kind of, okay, so wrong answer. Let us see what is that particular thing. So pushback and root is equal to roots, right? So I have returned the in order, and suppose s dot empty is equivalent to false. Okay, so here in this particular thing I have missed one condition, that is, okay, so root must not be equal to null or s dot empty. I have already said that the root must not be equal to null or the stack must not be equal to empty. If the root is not equal to null, then I am going to push that particular root inside my stack, and then I am going to move on to the, okay, so roots left. So now let us, okay, so run the code and let us check whether it works or not. Yeah, it's working fine now. So now I am going to submit this particular code. So yeah, it has been accepted, and the time is quite faster when compared to the recursive solution. So thanks a lot. So please subscribe to my channel. I am going to upload the entire questions, that means the unique questions from the lead code, so which will make you to crack the placements.